Hello everyone, welcome back to my channel. So till now we have discovered four kinds of operators. So we started with the operators. We have covered arithmetic operators, assignment operators, comparative, or we can say comparison operators, and logical operators. So in assignment we discussed about equal to. Arithmetic we had this, and in comparison we have less than, greater than, less than or equals to, greater than or equals to, equals to, and not equals to. After that we discussed logical operators. In logical we had and or, correct? We all know the use of this, and we all know how that this kind of operator works. Now, as we have discussed, today we are going to learn about few more operators. So the first operator today that we are going to learn is bitwise operator. All right, so let's get started with the bitwise operator. But yes, okay, so in bitwise operator we have and. Okay, so first operator that we are going to see is and. So previously we were having and we discussed that when we were dealing with the comparative operator or the comparison operator, we said that we use to equal to sign to compare two values like b and a. Okay, so now we raised a question that why there are two equals to, why not one equals to. So we discussed that if I use one equals to, which means it is I'm kind of doing a assignment, I'm not doing a comparison, correct? So that's the reason why it was said that we have to use two equal to operators or two equal to sign at the time of comparing two values. Now again, in the comparison operators we had two ands. Okay, now the reason for this is because one and is a kind of bitwise operator that we are going to learn today. So I hope this is clear to everyone that why do we use this and symbol and not only and, because and has different meaning. It is a bitwise operator, and so is or operator. So that is the reason why we used or like this. All right, so let's proceed with the first and operators, that is the bitwise operator. So in the bitwise operator, the first one that we are going to discuss is and. So now and means what? As I said, if both the values a and b, this was the comparative operator. So if both a and b returns true, if true and true, I say, then only I'll get true, correct? If this is false, then I'll get false, and if this is true and this is false, then also I'll get false. Am I right? Yes. So this is how the AND operator worked. But now how does this work? So this works all the bitwise. That's the reason why it has been said as bitwise. So the bitwise works on bits. Okay, so now for example, let's say I have x is equals to 1, y is equals to 3. Okay, so in binary they have some bit representation. So for 1 we'll have this set bit, for 3 we'll have this set bits, correct? So let's say 1 2 4 8 16 32 64 and so on, correct? So for 1 this is the representation in binary, and for 3 this is the binary representation for 3. If I do 1 and 3, which means it will perform the AND operation on these bits. Okay, it will perform the AND operation on these bits. So let's see what output we are going to get. So if I say AND and AND, or if I say AND with this 2 bit, what will happen? If this is set and this is set, then only we'll get the resultant, that is a set bit. But if any one of them, if either of them is not set, unset bit, then we'll get the output as 0 only. So now what is the output we get? we get output as 1 because this stands for value 1. Am I right? So let's try it in our code editor, then we'll again discuss with some few example, and then we'll get a better understanding about this. All right, so let me write int a is equals to 1, the same example that we have learned. Yes, if I say system.out.println, and if I say a and b, we have discussed the output about this, and the output comes out to be over here 0. Okay, sorry, the example that we discussed was 3. Yes, we get the desired output, but for 2 we were getting 0. Am I right? So the reason for this, you would have already guessed this. See, the binary starts with like this, correct? So for 1, which bit is set? This. For 2, this bit, and rest all are 0 bits, correct? So these are set as 0. Now if I perform AND, so both of them are 1 or not? No, they are, both of them are not 1, so I'll get the resultant as 0. Both of them are 1? No, I'll get the resultant as 0. So same, if both of them are same, we get the resultant same. So both of them are same, but over here we are different, both of them are different, then we get the resultant as always 0. So if both of them are 1 and 1, then only we will get the resultant as 1. Otherwise, if any one of them is not 1, then we'll get resultant as 0. So this is the logic for AND operator, correct? So that's the reason why for 2 we get the output as 0. So now let's discuss with some another examples. So let me write a representation for binary like this, and we'll have an example for this. So let's take a number, let's take 97 and 100. Okay, so if I want to do just a second. Yes, I want to do 97 and 100. Okay, so what will happen? How do I write 97 in this? 61 plus 32, what is this? 96 plus 1, correct? This is 97. How do I write 100? 64 plus 32 is 96 plus 4, correct? Rest all are zeros. All right, so now what will be the output if I perform AND operation on this? Are they both 1? No, 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 but over here they are 1, so we get the resultant as 1, and over here as well they are 1, so we get the resultant as 1 as well. So what will be the output? 64 plus 32, that is 96. So let's try this out. It was 97, I guess, and see, the value comes out to be 96. That's what we have discussed. So I hope AND operator is clear to all of you. Now if you don't know about the bits, then no worries, we are just completing this for getting the awareness that this stuff are also there in Java. So now let's discuss the another form. Now that let's discuss the another bitwise operator, that is OR. Okay, previously in the comparison we discussed OR like this was OR. Now in bitwise we have OR as well. So this is OR, a single pipe. Okay, so now how this single pipe works, we have already discussed. If either of the two values, if either of the two values is 1, then we'll get the resultant as 1, correct? Otherwise we'll get the resultant as 0. Am I right? All right, so let's try this out. So for let's discuss this example only. So 64, 32, 16, 8, 4, 2 and 1. How did we write 97? 1, 1, 0 0 0 1, and for 100 1 1 0 0 1 0 0. Correct. Now let's discuss the OR operation on this. We have discussed the AND operation, but now let's discuss the OR operation for this. So either one of them 1, correct, so we get the resultant as 1. Over here 0 1 0 0 1 1. So what is this? 96 plus 4 plus 1, that is 105 101. Am I right? Yes. All right, so let's try this out. So over here, if I say this, if I see, this is what the output that we have discussed. So I hope AND and OR operations are clear to all of you. You can note this chart down for getting a better understanding or just for reference. Yes. Okay, so now the another operator, the another bitwise operator that we are going to learn is XOR. Okay, so now we have to discuss what is XOR. See, what AND was, if both of them are 1, then we get the resultant as 1, otherwise we get the resultant as 0. For OR, how it was, if either one of them are 1. Okay, so let me have a generalized chart for the values like 1 1. These are the possibilities that we are going to get. All right, so for AND, how did this work, and for OR, and now for XOR. So for AND, if both of them are true, then we get the resultant and true. If both of them are not true, then 0 0. For XOR, if either one of them, okay, correct. But now, sorry, for OR, but now for XOR, it returns 1 only if one of the input is bit. Okay, so over here only one of the bit is set, and over here both of the bit are similar, correct. So we'll get 0 0 over here, but we'll get 1 and 1 over here. Am I right? Yes. So it doesn't return 1 if both of them are 1, because as I said, it returns 1 only if either one of them, not both of them. Okay, only if one of the two bits are set. So over here only one bit is set, that's the reason why we get the resultant as 1. But over here it was 0, so no sense of discussing this. But over here both of them were 1, that's the reason why we get the resultant as 0, not 1, because as I said, for XOR it will return 1 only if only one of the two bits are set. So let's discuss this. So if I say, let's take the same example for XOR, 97 XOR 100. So 64 32 16 8 4 2 and 1 1 1 0 0 0 0 1 1 1 0 0 1 0. Okay, now we want to perform the XOR. Either one of them are set, correct. Either one of them are set, correct. Both of them are set, we'll get the resultant as 0. So what output we are going to get? We are going to get output as 4 plus 1 5, correct. So let's try this out as well. So if I perform XOR over here, see, we get the resultant as 5. So I hope this is clear to every one of you. We have discussed AND, OR and XOR. See, you don't have to learn and go and learn about this binary stuff. If you know, then it's well and good. Okay, now we are going to perform the negations. So see, the negations is quite confusing, so we are not going into deep for this. But yes, the concept for this is simple, but the output that we are going to get is quite confusing. but you don't have to worry about this. And if you want to learn more, you can just go and search for it, and you will definitely get some good examples. But it is not like in this session we are not going much into the binaries, so that's the reason why we are not going to discuss about this in detail. But if you want, after completion of the course, we'll have some sessions for discussing or for solving some problem based on these operators. So let me just give you a quick brief of how negation works. So if I'm having 1, okay, so what is the bit, how do you set bit for 1? 1, 2, 4, 8, 16, 32, 64, and there are 32 bits like this. Okay, so this is the first 8 bits or 7 bits, correct? After this 128, this is the first 8 bits, and there are altogether 4 more sets in Java for this. Okay, so if I say for 1 and the rest are zeros, correct? So let me write 0 0 first. See, if I discuss this in detail today, it will be very confusing for you all. See, if I am declaring a variable int a is equals to 1, for int how many bytes? For int we have 4 bytes. So see, 1 byte corresponds to, or 1 byte equals to 8 bits. So these are 8 bits for 1 byte, correct? The second byte, the third byte, the 4 byte. So this is the representation for int in Java. Okay, so if I have 1, int a is equals to 1, this will be the set representation for it, this will be the bit representation, and the flag of this one will be set for it. I hope it is clear. Now if I do negation of 1, okay, if I do negation of a or negation of 1, what will happen? All the bits will get inverted. Okay, if it is 0, it will get converted to 1. And if it is 1, then it will get converted to 0. So over here, see, the value will be something weird. Don't worry about this, okay, because it is having some internal concepts of this, like the encoding stuff as well, and the signed bits as well. So that's the reason why we'll get the output as -2 for this. Okay, so don't worry about this, but you have to be sure that it will be not like -1 or -2 147 or something, not like that. It will be -2 for it. Okay, so let me just give you a example for this. So if I say negation of 1, see what output do we get. If I say negation of 3, will be -4. If I say negation of 128, it will be -129. Okay, so now don't go much deeper into this, that why it is coming out to be -129, because for int range we also have the negative representations. Okay, so it goes and set for them as well. All right, so don't worry about this. Okay, all right. And the reason why it is not coming out to be -128, because it is inverting, correct? So somewhere it will be like, if I'm having ranges from this, if I'm pointing this, so it will reflect to -128, correct? But the reason for this is we have 0 in between. Our index is start, means we count, means in general we count from 1 to 128, but in Java or in any programming language we count starts from, our count starts from 0 in bit representation, so it goes 1 ahead of it. Okay, so don't worry about this. Like, if you are getting confused, you can leave this stuff for now, but after getting understanding of all the concepts, you can give few time to this concept. So I hope for now it is clear to everyone. So the one that we focused much was this. Okay, so do you have any doubts till now? All right, so yes, see, now your question will be, why do we need this kind of operations? Means, what is the need of this? Correct. So as such, we do not use them much, but yes, they improves the speed of our code. So for example, if I say you that you have to check whether a number is even or odd, let's take 128. So what you will do, you will do mod of 2, correct? And if the resultant is equals to 0, or I can say if the remainder is equals to 0, then we have to say true, because yes, if the resultant is 0, then it is a even number. Now how you can do this with these operators, because what happens behind the scene is this thing is getting converted to bits, and this thing is again getting converted to bits, and then the operation is taking place. But instead, if you work directly on the bits, okay, so now let me tell you, let me give you a shortcut to do this. If this thing happens, then it is a even number. Now your question will be how? So for 128, let me write the, yes, for 128 it will be, the representation will be like this. And see, if any number is even, its last bit, or I can say the first bit for this position, will never be set. Okay, you can take any example. Okay, if it is let's say the number is 16, for 16 as well it won't be set. Okay, or let's say 140. So 140, for 140 what will be the representation? 128 plus 8 equals to 136 plus 4. Can you see, 140 is a even number, so that's the reason why its first bit is never set. So you can say that if it is a even number, its first bit is never set. To check the first bit representation, to check whether the first bit is set or not, you can just end it with this. If the result comes out to be 1, okay, which means this bit is set. But for now, if the result comes out to be 0, which means the first bit is not set, and we can say that it is a kind of even number. Correct. So yes, so in this way, see, you are directly working on the bits, so you are not transforming your code to bits, you are actually somehow like reducing the time complexity for your code. So yes, this is efficient than our previous approach of modulus, but then too you will always see the modulus approach, because it is the one that is being used by many of us. Okay, and even there are algorithms. See what happens when you learn DSA, there is a different section for this kind of topics, the bit magic it is called. So where we learn about, like, where we have operations or where we have problems that we can solve easily based on the bitwise operators. There are some algorithms as well. So for example, Brian Kernigham's algorithm, something like that. Yes, so in that as well we use the AND operators. So that's the reason why we, for now, we have to get aware about these concepts, like why they are being used. But afterward, when you move to DSA or any such thing, then you will have to learn into a much deep. See, the concept is still the same, but then the practice that is needed will be more and more to get the fluency of this stuff. So I hope it's clear to every one of you. All right, so now we have completed the 5 kinds of operators. Now the 6th kind that we are going to discuss is bit shift. Again, if this thing goes above your head, no worries, but just be sure that you know that these things exist in Java. So let's start with this as well. So there are, in bit shift we have 3 operators: right shift, left shift, and unsigned right shift. So don't worry about the signed and unsigned things, because we are not here to learn the bits. We are here to learn some operators, and we just want to understand the concepts for them, correct? So what happens with the shift? So for example, if I am having the left shift operator, if I take the left shift operator, so let's say I want to left shift 6 by 1. I know you don't understand this syntax. Let me write the bit, because we know that all of them are going to work on bits. So how do you write 6 in bit? 1 1, rest all zeros. So if you say left shift all the bits by 1, so which means you have to shift all of them by 1. Am I right? Yes. So this is nothing but the, just a second, yes, so this is nothing but the left shift operator. So I want to shift this to this, and over here 0 will come, so I will do this, and this will be transformed or goes over here, and this goes over here, and so on, correct? So what is the resultant value for this? 8 plus 4, that is 12. Am I right? All right, so let's try with some other values. So before that, I'll just do this system.out.println 6, shift this. Now again, yes, the output is 12. That's what we have discussed. So let's take some another example. So let me take 30. Okay, so how do you write 30? 1 1 1 1 and 0. Okay, 30 is a big number. Let's take this. Okay, so what is this? 14. All right, so I want to left shift 14 by 1. What happens? Shift this over here, shift this like this, correct, and 0 comes over here. So what is the value? 16 plus 8 plus 4, which is equivalent to 28, correct? Yes. Is it 28? Yes. Okay, so let's try this out. We set 14. Great. So now can you guess this, like what happens over here? What we are doing? We are just shifting the bits by 1. That's it. So if I shift the bits by 2, what will happen? It will get shifted by 2. So let me do this one as well. So I want to shift the bits by 2, correct? So let me shift the bits by 2. So this will come over here, and so on, correct? So 0 0, the first 2 will be 0 because I am shifting it by 2, and the rest will become 0 1 1 1 and the 0 0 0, like this. What will be the output? 32 plus 16 48 plus 8 56, correct? So let us try this. Can you see? We get the output that we have discussed. So this is how you can shift them as much as you can. Okay, like it's up to you how much or how many bits you shift them. All right, so what happens over here is, when you were doing 14 left shift by 1, it was like 14 into 2 power 1. We got the resultant as 28. Now I shifted it by 2, so it will be 2 power 2, that is 4. So 14 4s are 56. So this is the general formula for this, but yes, we need to know the bit representation for this. So I hope the left shift operator is clear to all of you. So the same way right shift operates, but it shifts the bit in the right side. All right, so yes, so now if I do Let's take an example. Okay, let's take this 6 only. Okay, now let me give the means, let us discuss this. So 64, 32, 16, 8, 4, 2 and 1. So for 6, these are the bits, so we have to right shift it, correct? So the 0 0 0 0 and 1 1, what will be the resultant? 3. So let's discuss this. System.out.println 6 right shift by 1. Can you see the resultant comes out to be 3 only? So let us do this. 14 right shift by 2. Okay, so how do you write 14? 1 1 1, correct? So all right, now I want to shift it by 2, correct? So this will come over here. See, now this, your question will be where will be this 2 will be going, correct? Means yes, means this byte will be going, correct, because there is nothing over here, so it will be dropped out. Okay, so if I say 0 0 and 1 1, so the resultant will be again 3. Let's see this. 14 2. See, can you guess the output? Yes. So this is what we have discussed. Okay, so if nothing is over here, the bit is dropped out, so we don't have to consider that bit. Okay, so do you have any doubts in this? You can ask me now. Do you have any doubts? Okay, so in this what happens is, for now you don't have to worry about sign bits. So if you use this sign is preserved, but there is another that is called as this. Okay, so over here if you use the 3 right shift operators, it works, means it again works the same way. Okay, but in this the sign is preserved. So if I do 14 like this, so the resultant will again be 3. So let's discuss this. See, these are same, but for now we don't have to worry about signed and unsigned bits. So if you want, after all the sessions we can have some sessions based on signed and unsigned bits, or all the computation of bit, like how bits perform, because if you don't know, then there is no sense of giving you incomplete knowledge about bits for now, because it is a good concept that need a dedicated section for bits. So don't worry about this, but for now we just need to be aware that these operators exist, and we have discussed and we have took some examples based on this. So these are the bit shift operators and these are the bitwise operators. So we have completed 6 kinds of operators till now. You are asking that how it is 3, how this comes out to be 3. So let me explain it again. So right, 64, 32, 16, 8, 4, 2 and 1. How do you write 14? 8 plus 4 plus 2 and rest all 0. You want to shift 2 times, correct, means the right shift twice. So is there any values after this? So you have to drop this, correct, and now you have to drop this, correct. So 1 bit is getting dropped, nothing comes over here. See, we'll go in a sequence, just a second. Yes, how you have to perform this, you have to shift 0 to 2 bits ahead. Is there anything? No. So this gets dropped. You have to shift this 2 bits ahead. Is there anything over here? No. You have to again drop this. Now you have to shift this 2 bit ahead. Is there a bit over here? Yes. You can set this out. Now you have to set this over here. See, this becomes 0 now because this has set this one. This has been shifted towards right 2 positions, correct? Now this has to get shifted over here. So this will become 1 and this will again become 0, and this same thing happens, like this 0 comes from over here only. Okay, so what is the resultant? 2 plus 1, that is 3. So let me again give you, let me take another example now, then you will be able to get a clear idea about this. So let me take 48. Okay, how do you write 48? 31 plus 16 is 48. Let me right shift it by 2. Okay, I have to right shift it by 2. You can use any operators over here because it is positive, no worries. Okay, so nothing over here dropped, it becomes 0. It is always 0. Again 0, 0. See what happens, this drops. Okay, nothing over here. The previous bits drop, nothing over here. Okay, but now these bytes are, means these bits are again going to get over here. So this becomes 0, this becomes 0. Now this has to come over here and this has to come over here, and the previous bits has to come over here. So this takes place like this takes place continuously like in this fashion. So if I say you have to again, yes, right shift this. Okay, sorry, right shift 48 by 2. So what will happen, you just take this sign bit and shift it by 2. Rest all are always going to be 0. So what will be the output? Okay, for this 48, what will be the output? It is 8 plus 4, that is coming out to be 12. But for 14 it was 1, 1, 1 and 0. So what was this? This is going to get dropped. The rest two are going to come over here. One over here and the other are always 0. So correct. So let me take the 14th example again and then it will be clear to all of you. Yes. So how do you write 14? Like this. So you have to shift it 2 times or 2 position right, nothing over here, which means this is going to get dropped. Now you can shift only these 2 over at this place, correct? So what you will do, you will do this. What is the resultant? 2 plus 1, that is 3. So I hope it is clear to everyone. So this is the idea, that for example you have to shift 96 4 times. Okay, 4 bytes. So how do you write 96? Like this. So where this will go, this will come over here, correct? 1 2 3 4, you have to set the bits over here, correct? So which means 1 and rest all are zeros, correct? So we'll get the output as, yes, we'll get the output as 6. So this is how we transform them. So I hope it is clear to all of you. So again, let's take the 14th one. You have to shift them by, if you have to shift them by 1, what will happen? All of them are going to get shifted 1 ahead. So 0 1 1 1. What will be the output? 4 plus 2 6 plus 1 7. But we have to shift them by 2. So what will happen? There is no second position after this. So this is going to get dropped, but the rest 2 is going to come over here. So 0 0 1 1. So what will be the output? The output will be 3. So I hope, yes, it is clear to everyone. Yes. So the one thing is, as I said, if you are learning DSA, there is a dedicated section for all of this, in which XOR and OR are the most used one. Okay. So when you go into that topic, you will learn a lot about this. See, the concept is always the same, the concept that we have discussed, but to get a better understanding, you need to practice about this, and there are several means I can say that there are a lot of questions. So for example, there is a question you have to check that whether a number is power of 2 or not. Okay, I'll just give you the way how to solve this. Okay, so for example, let's say, is 64 a power of 2? Yes, correct. 2, correct. So 2 power 6 is 64, I guess, correct. So is 36 a power of 2? No. Is 32 a power of 2? Yes. 2, 4, 8, 16 and 32. Yes, 32 is a power of 2. 128 power of 2, correct. 2 power of 2, correct. 1 power of 2, yes. 2 power 0 is 1. 46 power of 2, no. See, they are multiples of 2, but they are not power of 2. Okay, now to deal with this question, what is the trick is, so for example, if you don't understand, don't have to worry about this, but I'll just give you a understanding that how this thing can be useful. Okay, so let me say 64, 32, 16, 8, 4, 2, 1. So have you guys noticed that these bytes, okay, these bits are nothing but power of 2s. Okay, which means if I am taking 64, which means only one bit is going to get set, which means if it is a power of 2, only one bit is going to get set. If I say 16, which means only 16 is going to get set and all of them are going to get zeros. Am I right? So if I say 46, it is not power of 2, which means multiple values are going to get set. Am I right? So for 46, what we have to write is 34 plus 16 is 48, I guess. Yes, so we don't have to take this 40 and this will be for 46. So 46 is not a power of 2, which means if a number is a power of 2, only one bit is going to get set. We can say that for now, and the rest, the other bits prior to this are going to get zeros. So to check whether a number is a power of 2 or not, you just have to do it number minus 1 and AND operator with this. So for example, if you want to check 32 is power of 2 or not, you just have to do 32 and 31, which is, so if you want to check whether n is power of 2 or not, n and n minus 1, that's it. This is the, and this takes constant time. Okay, there are time complexity that you need to consider while problem solving, so we are not doing that for now, but yes, I'm just giving you an example that how this thing can be helpful. So this states that, see what happens, how do you represent 63? 63 is represented like this. Okay, how do you represent 31? 30, for 31, the bit prior to 32 will be set as 1. So if you do AND with this, what will be the resultant? The resultant will be 0, and if it is not 0, if it is other than 0, then it is not a power of 2. So let me give you an example. So let me say 16. Is 16 power of 2? Definitely yes. So for 16, it will be like this. What we have said, we have to do 16 and 16 minus 1. That is 16 and 15. How do you write 15? 8 plus 4 plus 2 plus 1. This is 15. You have to do AND 0, 0, not similar 0, not similar 0, not similar, not similar. The resultant is 0, which means 16 is a power of 2. And over here, if I take another example, so let me take example as 20. Okay, what you have to do is, what you have to check is whether 20 and 20 minus 1, that is 20 and 19, is equals to 0, then it is power of 2, and if it is not, if this gives false, then it is not power of 0. So how do you write 20? 16 plus 4, correct? Am I right? Yes, rest all are 0. So if you do AND with 19, how do you write 19? 16 plus 3. If you do AND, over here we get 1 0 0 0 0. So what is the resultant? We get the resultant as 16, which is not equals to 0, which means 20 is not a power of 2. I hope this problem is clear to everyone, and this gives you a better understanding that how you can use bitwise operators and how this can be useful while problem solving. So there are some dedicated problems, you can Google it, don't worry about this. Yes, I would have explained you the Brian Kernigham's algorithm as well, but we have not discussed loop yet, so don't worry. Alright, so the one thing that other application of these operators are, these are much being used in like hash tables, Java hash maps, or to be precise, we use them in embedded programmings or games programming. Okay, so like in normal development these are not much being used, but while in DSA or embedded systems gamings, these are being used, or where the system which don't have any floating point numbers, at that time we use this kind of operators. But yes, we need to get an understanding of this, and we have completed that. So now the last one, see, as I said that there are altogether 7 kinds of operators. So first one was assignment operators, second one was arithmetic, comparison, logical, bitwise, and bit shift. So the last one that we are going to discuss is Instanceof. Again, you won't see this much often, but then too it is a kind of operator, and we are going to learn that. So in assignment we discussed this, over here we discussed this. For comparison, this is slash. Okay, for comparison we have, sorry, correct. For logical we had and then an or. For this we had this for, and now the only thing that is remaining is Instanceof. So let's discuss this. How do we use Instanceof operator? It is quite easy. So what do you mean by instance? Instance, we can say that it is a kind of object, or we can say it is an object only. Okay, so if I say student is my class, how do I create an object of it? You will say student s is equals to new student, correct? We know this syntax very well. So if I ask you, is s a object of student, what will be your answer? You will say yes, because it is being created using this blueprint, because I have specified the type. So that's it. To check whether it is a object of this class or not, we can use the Instanceof operator. Okay, so yes, so now, okay, so let's try this out. Okay, oh, let's move down to our student class. System.out.println. See, we get the output as true, because we know that the s that we have discussed, okay, the s that we have declared over here is a object of our student class, because it is of type student. So if we have to check, if we want to check whether a object is a type, or whether this points to our, means whether this is created using our student class or not, or we want to check whether s is a object of student or not, then we can use the instance of operator. So if I say s2, okay, just a second, yeah, if I say s2 instance of, okay, it is all small, instance of student, what will be your answer? It will return true, because yes, s2 is again the object of student. So I hope instance of is clear to everyone. And yes, so as I have said that strings, okay, strings are also object. So if I say yes, so you don't know how strings are getting assigned, but as I said, strings are also object because they are non-primitive. Okay, so if I say s instance of, for this example, okay, or let me take another examples, string z equals to some values, okay, don't worry about this. So if I say z instance of string, what will be your answer? What will you conclude after seeing this? The answer is true, definitely, because strings object can be created and z is the object of string, or we can say instance of string. So this is how instance of operators is being used. So there can be scenarios while developing some projects or any frameworks, there can be scenarios where you have to check whether a object is a instance of some class or not. At that time you can use the instance of operators. Okay, so I hope till now it is clear to every one of you. So if you have any doubts, like, do you have any doubts? If you have any doubts, you can ask me now in the chat box, or after the session as well, you can ask me in the comment section. I will reply to each of your doubts. So we have discussed all the operators, the assignment operators, the arithmetic operators, the comparison. Okay, so let me write the operators. The equals to, the arithmetic, the comparison, the logical, the bitwise, the bit shift, and the instance of. So this completes our operator stuff. We also know how operands get promoted. So we have discussed operand promotions as well. When does the promotion takes place, and why do we get some values? Like if I say 16 divided by 5, why do we get 3 only? Why it is not giving the values in point? Because int will give the resultant in int. We have discussed this. So operand promotions, we know the rules. So now we are good to go with loops and conditional statements, because if we have directly started with loops, then we might get confused at some point that if we get some weird values. So now I hope it's clear to everyone, and if you have any doubts, you can just post your doubts in the comment section. So for now, I'm just dropping the stream, and see you all tomorrow at the same time. So thank you everyone for joining today's session. Thank you.